In this video, we're going to take the basic forms of factoring that we practiced in the previous one, and we're going to extend them into problems that are more pre-calculus level factoring. So let's start with the first type of factoring that we did in the last video, which was greatest common factor. And in the first couple of problems, I want to just factor out the greatest common factor. So if you remember, for example number 1, say we factored 5a to the 30th plus 7a to the 29th by factoring out the greatest common factor. So clearly there is no common factor between 5 and 7. However, both terms share a's. And we always factor out the smallest exponent we see, which would be a to the 29, because this term has 29 a's to give us, and this term has 29 a's to give us. If we take out 30, that works for the first term, but it doesn't work for the second term. So we always take the smallest exponent. So that would leave us with a 5 and a single a in the first term, and then 7, but all the a's came out in the second term. Now let's extend that idea to some more challenging examples. So let's try x to the 3/7 plus x to the 1/7. Okay. The important thing to notice here is the smallest exponent. Same exact idea as the previous one, but we're looking for, remember, the smallest exponent. So the smaller number between a 3/7 and a 1/7 is the 1/7. So we'll factor out the x to the 1/7. When we do that, remember that we're subtracting exponents. So, right, when we factored out the 29 a's from the 30 a's, we had 30 minus 29 to give us an a to the 1. So in this part of the problem, we have 3/7 minus 1/7 as an exponent on the x, or if I rewrote that, that would be 3 minus 1 is 2. And then the next term, when we take x to the 1/7 away from x to the 1/7, all that's left is a 1. Remember, we're doing division here, so we don't have zeros left over. That's for adding and subtracting. So I have x to the 1/7 times the quantity, x to the 2/7 plus 1. Okay, let's try another example really similar to number 2, because number 2 can get confusing. Let's try 9x to the 7/4 minus 2x to the 3/2 plus 19x to the 5/4. Well, for starters, this is a little difficult to find the smallest exponent because they're not written with common denominators. So let's change them all to having the same denominator of 4, which means this would be needed to we need to multiply by 2 over 2, making that 6/4. Okay, great. Let's rewrite that. 9x to the 7/4 minus 2x now to the 6/4 plus 19x to the 5/4. Okay. For the coefficients, 9, 2, and 19, there's nothing common that goes into them. And for the x's, since every term has an x, we can factor out some x's and we'll take the smallest exponent, which is 5/4. And when we figure out the remainder, we're going to subtract exponents. So we'll still have a 9 left over for the first term, but x to the 7/4 divided by x to the 5/4 is x to the, I'll leave it 2/4 for right now, and reduce the fraction in a second. In the middle term, we still have our -2, x to the 6/4 minus 5/4 is 1/4. And in the final term, x to the 5/4 divided by x to the 5/4 is no x's, just a 1. So we have plus the 19 that's left. Okay, let me fit one more on this page that's similar, but a slightly different concept, and I want to change colors so you can tell them apart. Let's go to purple. Okay, let's do example number 4. So for example number 4, let's try 5x to the -2 plus 5x to the -3 plus 35x to the -4. Okay, if we're taking out the greatest common factor here, oh, hey, there is a greatest common factor with our coefficients in this one. 5 goes into 5 and 5 and 35, so we'll factor out a 5. Okay, now be careful with negative numbers. The smallest number between a -2, a -3, and a -4 is the -4. So the smallest number between the -2, the -3, and the -4 is in fact the -4. Furthermore, remember, we're subtracting exponents. So in the first term, while the 5's cancel, the exponent we have left on the x was a -2, and now we're subtracting -4. And subtracting an extra negative, subtracting a negative is adding. So this will turn into 5x to the -4, x times the quantity x squared in our first term. In the second term, the 5's cancel again, and we're left with -3 minus -4 for the exponent. Again, subtracting a negative changes it to a positive, so this will be plus x to the 1, or just plus x. And in the last term, thankfully, the x and the -4's cancel, and 5 goes into 35 7 times, so plus 7. Even if you've done the previous homework problems where you've factored trinomials, you can probably tell that this one does not factor x squared plus x plus 7, does not factor any further. There are no numbers that both multiply to 7 and add to be 1. So this x squared plus x plus 7 is prime itself. It doesn't factor anymore. Okay, let's try a couple more problems. Okay, let's do some more ugly greatest common factor problems. So for our next example, so picking up with example 5, let's do a warm-up problem. Let's do 3a to the 37 plus 7a to the 36th. Okay, bear with my color coding for just a second. Okay, same idea. We're factoring out the GCF, nothing common between a 3 and a 7, but there are a's in both of them. And so we're going to factor out, like we have been doing, the smaller of the two exponents. So this would be a to the 36. And what's left over is 3a plus 7. Okay, straightforward enough. Okay, now I want to try another one really similar. I'm going to use the same colors for this one. In this problem, I want to do 3 times the quantity 5x minus 8 to the 37th plus 7 times the quantity 5x minus 8 to the 36th. And I'm color coding these in this way for a really important reason. Number 5 and number 6 are done in an identical fashion. So for number 5, it was pretty easy to see that a was the common factor and the smallest exponent was 36 on the a's. So we took out a to the 36th. For number 6, the common factor here is, again, the red portion, the 5x minus 8 in parentheses. So one very nice, quick way to do this problem is to factor out the 5x minus 8, just like we did the a's. The smallest exponent on the 5x minus 8 is the 36, and what's left over is 3 times 1 5x minus 8 plus 7 times no 5x minus 8s, because it was 5x minus 8 to the 36th. Take away 5x minus 8 to the 36th. So what we have left over on the inside is pretty easy to simplify. I'm not concerned that you can distribute and combine your like terms. I'm more concerned with this step here that we just did. So we basically just treated the 5x minus 8 kind of like the grouping problems we were doing before, like a common factor, and factored out the smallest exponent. And then wrote what's left over in the parentheses. So when we clean that up, we'll have 5x minus 8 to the 36 times, let's see, this is going to be, 3 times 5 is 15x minus 24 plus 7. So that'll turn into 15x, and negative 24 plus 7 is negative 17. Okay. I want to do a couple more that are similar to this one because it's a tricky type of problem. So let's do another one. Let's do 11 times the quantity 3x minus 8 to the 47th minus 2 times the quantity 3x minus 8 to the 46th. Now, one thing that you could do is you could turn this problem, number 7, into something that looks more like number 5 if this didn't make sense to you in number 6. So first, let me show you how to do that. You could take the inside, the 3x minus 8, which is common in each one of them, and perhaps let a equal 3x minus 8. That would turn your problem into 11a to the 47th minus 2a to the 46th. And then the problem looks just like number 5 did. There are 46 a's as the smallest exponent, so we can factor out a to the 46th. And what we're left over with is 11a minus 2. Oops, I want to make that a green. Just to be consistent. There we go. The only problem is if we do it this way with substitution, we do need to go back to whatever a was. So we need to go back and re-substitute in. A was 3x minus 8. So it'll be 3x minus 8 to the 46th times 11 times 3x minus 8 minus 2. So the 3x minus 8 and the 3x minus 8 are just where the a's were. Okay, and then the very last thing to do would be like we did in the previous problem, number 6, distribute that 11 through, make that 33x minus 88 minus 2. So our answer is 3x minus 8 to the 46 times 33x minus 90. All finished. Okay, if you want to, you can skip this step. This substitution with a being what's the same is totally optional. Some students really find it helps them make the problem a lot simpler, and other students find that they can skip down to this step down here without doing any a substitutions. Okay, let's try a couple more types of these and then we will be done. All right, last couple problems. Let's sort of combine all of these ugly GCF methods we've been practicing. So let's factor the following. 5 times the quantity x plus 4 to the negative fourth plus 9 times the quantity x plus 4 to the negative third. Okay. Definitely a common factor with these x plus 4s, but not with the 5 and the 9. The next one we do will have a common factor with the coefficients. So I'm going to do the problem this way. I'm going to do the problem with substitution just so people can practice. So I'm going to let what's common be my a's. So I'm going to let a be x plus 4. And that makes this problem 5a to the negative 4 plus 9a to the negative 3. Now it looks similar to the ones we were doing at the beginning of this video. Let's see, I can take out a's. The smaller exponent between a negative 4 and a negative 3 is the negative 4. And that just leaves me with 5 for the first term, but 9a to the negative 3 becomes, oh, I'm so bad with negatives. Let's try this. Try this here. Becomes 9a, and I'm going to write in negative 3 minus the negative 4. Existing exponent minus the one you're taking out. Okay, minus a negative turns into positive. So now we have a to the negative 4 times 5 plus 9a to the 1. Okay. The only bummer part about doing that a substitution is don't forget to plug it back in at the end. So a was x plus 4. So we have x plus 4 to the negative fourth, and 5 plus 9 times the quantity x plus 4. That's going to turn into 5 plus 9x plus 36. So we have x plus 4 to the negative 4 times, let's see, 9x plus 41. Terrific. Okay, let's do another one that's really similar to that. So now let's factor 7 times the quantity x plus 1 to the negative 5 times x minus 3 to the 90th plus 28 times the quantity x plus 1 to the negative 6 times the quantity x minus 3 to the 91st. Awesome. Okay, so we have two different substitutions to make. I think we'll let the x plus 1s be a's. So a should equal x plus 1. And then how about we let b equal x minus 3? That is in the second parentheses. And then let's see what we get when we make that simplifying substitution. So 7 a to the negative 5, b to the 90, plus 28, a to the negative 6, b to the 91. Okay. Okay, lots of common factors here. So first of all, between the 7 and the 28, we can factor out the 7. For the a's, the smallest exponent is the negative 6. So we'll factor out a to the negative 6. And for the b's, the smallest exponent is the 90. So we'll factor out b to the 90 and see what we have left over. Okay, first term, 7 goes into 7 evenly, so that cancels to 1. Negatives, bane of my existence. Okay, be real careful. Existing exponent minus factored out exponent. Negative 5 minus negative 6. Okay, I don't probably have to write that for the b's. 90 minus 90 is 0, so there are no b's in there. But for those a's, I sure do. So that's going to turn into 7a to the negative 6, b to the 90, times the quantity a to the 1, so just a. And then we have plus, 7 goes into 28 4 times. A to the negative 6, taken out of a to the negative 6 is 1. And b to the 91 divided by b to the 90 is b to the 1. So just b. So we have a plus 4b left in the parentheses. Now, if you could do that without using the AB substitution, that's super impressive. I find it much more difficult to do in this particular problem. Negative exponents are tricky, and the two substitutions make it tricky. This substitution thing makes it, doing the substitutions makes it so much simpler. Just don't forget to go all the way back. So this would be 7, let's see, A was x plus 1, negative 6. What was B? X minus 3 to the 90. And then for A, we have x plus 1 plus 4b, x minus 3. So 4 times x minus 3. Do a little highlighting to see the A and the B here. Okay. And then inside, let's see, that would be, x plus 1 does not need the parentheses around it. That's just there to show what A used to be. But the x minus 3 does because of the 4. So that will be x plus 1 plus 4x minus 12. Making our final answer this. 7 times x plus 1 to the negative 6 times x minus 3 to the 90 times 5x, so 4x plus x, minus 11. Awesome. Okay, let's do one last problem. Final problem, question number 10. Let's factor x to the negative 2/7 times the quantity 6x plus 1 to the 10th minus x to the 5/7 times the quantity 6x plus 1 to the 9th. Okay, it's got it all. Negative exponents, fractions, and even possibly a substitution. So let's let that substitution 6x plus 1 be represented by A. Great. So then we have, x to the negative 2/7 times A to the 10th minus x to the 5/7 times A to the 9th. Very good. Okay, common factors. Common factor between, there's definitely x's in each of those. Between x to the negative 2/7 and x to the positive 5/7 is the negative one. That's the smallest exponent. So negative 2/7 is what we'll factor out. And certainly the common factor between a to the 10 and a to the 9 is a to the 9. Okay, the leftovers. X to the negative 2/7 taken away from x to the negative 2/7 cancels, and a to the 10 divided by a to the 9 is just a to the 1. In the second one, I have a little bit of subtraction to do with fractions, so I'm going to write this step in here. Existing exponent, 5/7, minus factored out exponent, negative 2/7, because we're dividing. That's why we're going to subtract our exponents, because we're dividing. So again, the minus and negative will turn positive. 5/7 plus 2/7. It's too easy. It's 1. That's awesome. And then a to the 9th taken away from a to the 9th is 1. So we're left with x to the negative 2/7 a to the 9th times the quantity a minus x. Or back to x's exclusively, x to the negative 2/7. Let's see, what was a? 6x plus 1 to the 9th times 6x plus 1 minus x. Those parentheses that I put around the 6x plus 1 are not necessary, that nothing's getting distributed. So 6x plus 1 minus x is 5x plus 1. So here's our answer. X to the negative 2/7 times 6x plus 1 to the 9th times 5x plus 1. Awesome.